Today we're going to look at graphing a quadratic equation that's written in standard form. Standard form would be if the equation is written as y equals here. If the equation is written as y equals ax squared plus bx plus c. The a value does the same thing in standard form that it did in vertex form. That is, if a is greater than 0, then the parabola opens up. And if a is less than 0, then the parabola opens down. So for the example over here, we say the a value is 1, which means our parabola is going to open up. And then also, just like with the vertex form, if that value of a, disregarding the positive or negative, so the absolute value of a, if it's bigger than 1, then you have a skinny parabola. And if that value of a, disregarding the sign, is less than 1, then you have a wider parabola. And if that value of a, again, disregarding the sign, is equal to 1, then you just have your average width parabola. So again, going to our example, since a is 1, that means it's the average width. Now in the vertex form, so this is going to be standard form, and then this is vertex form, which we looked at last week. In a vertex form, you're given y equals a times x minus h, that quantity squared plus k. And the vertex was easy to find just by looking at the equation. Your h and your k was your vertex. So that's what we had before. Now for standard form, we don't have the vertex sitting right there in front of the equation. So to find the vertex in standard form, you first find the x part of the ordered pair. By doing the opposite of b over 2a. So in our example, our b value is -6. So we're doing opposite of b over 2a. So the opposite of -6 would be a +6 over 2 times 1 gives us 3. That's going to be the x part of a vertex. To find the y value of the ordered pair, you're simply going to plug in the -b over 2a number into the equation. Plug in that -b over 2a number for x in the original equation. So for us, we're going to do y equals 3 squared for x squared minus 6 times 3, we know x is 3, plus 7. That's going to give us -2. So we know our vertex is at 3, -2. Everything else is going to be identical to what we did in vertex form. Axis symmetry is still going to be x equals whatever the x part of a vertex was. Change colors here. So x equals 3. The y-intercept we still find by letting x be 0. When x is 0, we find y is 7. The symmetric point we find by counting over from the axis symmetry to the y-intercept and count the same number of units in the other direction. That's going to put us at 6, 7. We still save x-intercepts for last because we may or may not have them. In this case, we will have x-intercepts because we know it's going to open up and cross the x-axis. So to find x-intercepts, we simply let y be 0 and solve. So if y is 0, we have 0 equals x squared minus 6x plus 7. I think that was the equation. Yeah. We can solve this by factoring if it's factorable or by using the quadratic formula. In this case, I don't think it factors. Two numbers that multiply to 7 add up to 6. 1, 7, -1, -7. Yeah, none of them add up to 6. So if you use a quadratic formula, we know it's the opposite of b. Let me write it out here real quick. So opposite of b plus or minus the square root of b squared minus 4ac all over 2a. So we end up with 6 plus or minus the square root of 36 for -6 squared minus 4 times a is 1 times c is 7 all over 2 times a, which is 1. That gives us 36 minus 28 all over 2. So we end up with 6 plus or minus the square root of 8 all over 2. And we can simplify that a little bit by breaking down root 8 to get 2 root 2. Taking it 2 out of everything. Which is the same thing as 3 plus or minus the square root of 2. And you can certainly put those in the calculator to find out about where it crosses in terms of a decimal approximation. Whoops. So if we do 3 plus the square root of 2, gives us 4.4. So right about here. And if we do 3 minus the square root of 2, it gives us 1.58. So right about there. And then connect them with a U-shaped curve. And there's your parabola. So again, the key here, the only difference, the new thing is this piece here. The vertex is the opposite of b over 2a to find the x part, and then whatever the x value is, plug that back into the equation for x, solve for y, and that's your vertex. Everything else is identical to what we did in vertex form. So we'll go through this one real quick. Again, a is a negative number. That tells us that it opens down. That number is bigger than 1. That means it's going to be skinnier, the absolute value of the number. And the vertex, we're going to do opposite of b over 2a. That's going to be 12, negative 12 over 2 times a is negative 2. That gives us negative 12 over negative 4, which is 3. So our vertex is going to be 3, comma, and to find the y value, we're going to plug that 3 in for the x. So -2 instead of x squared, we have 3 squared, plus 12 times instead of x, we have 3, and then minus 9. That gives us -18 plus 36 minus 9, which is 9. So vertex is 3, 9. 1, 2, 3, 1, 2. Axis symmetry, just x equals whatever the x part of your vertex is. Y-intercept, let x be 0, and solve, we get -9. That symmetric point, we're going to count over to the axis symmetry, 1, 2, 3 units. Go 3 units the other direction. And here's your symmetric point. That's going to be 6, -9. And then find your x-intercepts by letting y be 0. Again, you can try factoring, quadratic formula. We'll do quadratic formula here. Opposite of b plus or minus the square root of b squared. And we're doing x-intercepts because we know that this graph's going to cross, the problem is going to cross the x-axis somewhere. So we know that we do have x-intercepts. So b squared minus 4ac all over 2a. So this is going to give us 144. And I know negative times negative times a negative is negative. And 4 times 2 is 8 times 9 is 72 over -4. So we have -12 plus or minus. And 144 minus 72 is 72 over -4. And we can break down root 72. That's going to give me 2 and 36. 6 and 6. I have a pair of 6s, so I know a 6 comes out. A 2 stays in. If I divide all these numbers by -2, end up with 6 plus or minus -3 root 2 over 2, dividing everything by -2. Now if I do plus or minus negative, I can do plus a negative, gives me a negative, or I can do minus negative, gives me a positive. So it's still plus or minus. So those are my x-intercepts. So 6 plus root 3, or was it root 3? 3 root 2. Over 0 over 2, comma 0, and 6 minus 3 root 2 over 2. Again, plug them in the calculator to get approximate values. And then connect them with a U-shaped parabola. And that's it. So just like with vertex form, it's the exact same process, except the vertex is found by doing opposite of b over 2a and then plugging that number in.